As a philosopher, I bet you're pretty good at taking definitions apart and figuring out all the assumptions behind them. But what happens when we try to do that with something that seems super simple on the surface but gets really complicated really fast, like, say, risk?
It does get slippery very quickly.
Welcome to the deep dive. And this time we're going deep, really deep into the philosophy of risk.
Really fascinating stuff. And, you sent me this amazing entry from the Stanford Encyclopedia of Philosophy on risk, of course. It's a really comprehensive piece. I mean, it brings together so much work from different fields, not just philosophy. And then it makes these really cool connections back to some of the big questions in philosophy itself.
Yeah, totally. And for you listening, as a philosopher, you're already thinking about super complex stuff all the time. So we think this deep dive could be really eye-opening for you. Getting a grip on all the little details of risk. I mean, it pops up everywhere, from epistemology to ethics. It could give you some fresh ways to think about your own philosophical work. So what we're going to do today is unpack all the main philosophical stuff about risk that's laid out in this source.
And one thing that struck me right away, the source points out that not that many philosophers have really focused on risk directly, like
Right.
made it the main topic of their work. That's kind of surprising, right?
Yeah.
Especially when you think about how important risk is to so many different areas of philosophy. It's like philosophy has this blind spot when it comes to risk.
Yeah, it is interesting. Do you think it's because risk is so often about probability and things that might happen but might not? Maybe it just feels too messy for traditional philosophy, which loves certainty and logic and all that.
That's a very good point.
So, okay, let's dive into this philosophical blind spot, right? In everyday language, we all kind of know what we mean by risk. It's like the chance that something bad will happen. But as soon as you try to make that into a precise definition, things get complicated, fast. Like the source actually breaks down risk into 5 different technical meanings that get used in all sorts of fields.
It's true. It's really surprising how the everyday idea of risk can be so different from these more technical ways of defining it. So, the first definition that the source gives is pretty basic. Risk is an unwanted event that may or may not happen. So, if you're a smoker, there's a risk of getting lung cancer, that kind of thing.
Right, right. And the second definition is kind of similar, but it shifts the focus to the cause of the bad thing that might happen.
Hmm.
So in that smoking example, smoking itself is the risk, not lung cancer.
So, both of those are qualitative ways of thinking about risk.
Yes, exactly. Okay. But then things get more quantitative. The third definition is probably the one that makes the most sense to most people. Risk is the probability of that unwanted event happening. So you could say there's a 50% risk that smoking will shorten your life, something like that.
Right. And that's a definition we hear all the time.
And then it gets a little more complicated with the fourth definition, risk as the statistical expectation value. This is where you actually multiply the probability of the bad thing happening by how bad it would be if it did happen.
Hmm.
So the source uses the example of the expected number of deaths in an accident.
Yeah, interesting example. It is kind of strange to think about this. The math behind expectation value has been around for ages, but using it to define risk is a much more recent thing. It really took off after that big reactor safety study back in the 70s.
Oh, wow. I didn't know that.
Yeah. And now, some people who analyze risk actually think this is the only right way to use the term risk. Kind of a bold statement, don't you think?
Yeah, it is. And then there's that fifth definition. This one is kind of interesting because it's all about making decisions.
Mhm.
Risk is when you have to make a decision when you know the probabilities of what might happen. The source is careful to point out that this is different from what they call decision under uncertainty.
Yeah. You're basically talking about two different kinds of information environments when you make a decision.
Exactly. But it's important to remember the source makes it clear that these 5 ways of thinking about risk, they're not the whole story. Other fields like economics, which we'll get to later, they have their own special definitions that work for what they're doing.
Different tools for different jobs, you could say.
Exactly, yeah.
Yeah.
But for us philosophers, this is where things get really interesting. The course points out that some philosophers think these technical definitions are too narrow. They say these definitions miss some really important stuff that we should think about when we're trying to understand risk from a philosophical point of view.
Yeah, like missing the forest for the trees. Focusing too much on the numbers and missing the bigger picture. Like philosophers such as Lara Buchak, Duncan Pritchard, and Kristen Schrader-Frechette. The source mentions them. They've argued that these technical definitions just don't capture all the ethical and epistemological angles of risk. There's more to it than just the numbers.
And it seems like most people, when they talk about risk in everyday life, they're not using these super precise technical definitions. The source actually brings up linguistic evidence that shows our everyday use of risk is still really broad and informal, even though all these specialized meanings are out there.
It's a really interesting disconnect. Like, the experts are talking about risk in one way, but the public might be understanding it in a totally different way. And you can see how that could cause problems, especially when it comes to making policy decisions or communicating about important issues.
Oh, absolutely. Before we move on, just a quick note for everyone listening. When the source talks about probability, they're using it in a broad sense.
Right.
They mean both the subjective feeling you have about how likely something is and the objective, measurable frequency of something happening.
Good clarification. Always good to be on the same page.
Okay, so figuring out what risk even means is a whole philosophical project in itself. But let's move on to the epistemological problems that come up when you think about risk. Risk is all about dealing with the unknown, with stuff that might happen. Like the source says, knowing about risk means knowing about what you don't know.
Right, it's about the limits of our knowledge. And the source makes this really interesting point about the difference between risk and uncertainty. In everyday language, we sort of use them differently. Uncertainty is often about you not knowing something, like you're not sure if that mushroom is poisonous, but risk seems to be about something being objectively dangerous, whether you know it or not. If that mushroom is poisonous, there's a risk, even if you think it's safe to eat.
Yeah, okay, so kind of like truth versus belief in a way.
Exactly. But here's the thing. Decision theory uses these terms in a totally different way. For decision theorists, risk is when you know the probabilities of different things happening. And uncertainty is when you don't know those probabilities, or you only know them partially.
Whoa, that's kind of a mind bender. So for them, even if you're just guessing about the chance of rain tomorrow, that's already a risk.
Exactly. But if you're just like, yeah, it might rain, with no numbers attached, that's uncertainty.
Okay. The source also has a section about making decisions when you have literally no information about probabilities, which they call decision under ignorance. That sounds like a really tricky situation.
Yeah, a tough spot to be in. But here's the thing, and this is where it gets really philosophical. The source points out that in the real world, truly knowing probabilities is super rare. We're talking textbook examples like flipping a coin or rolling a die.
Yeah, those are easy.
In real life, almost every time we're dealing with risk, there's some level of uncertainty baked into those probabilities. It might look like we have precise numbers, but those numbers are based on models, assumptions, and data that all have their own limitations.
That's so true. So really, almost all our decisions are made under some level of uncertainty, right? We're just pretending we know the probabilities for sure because it makes things easier to think about.
It's a useful simplification, and that's exactly what decision theory often does. It simplifies things to make them more manageable.
Right. But this simplification brings up a huge challenge, especially for philosophers. How do we deal with the fact that we just don't know enough about these massive, complex systems that we need to assess for risk, like the climate or ecosystems or the economy? There's so many moving parts that it's just impossible to predict exactly what will happen.
It's true. They're inherently unpredictable in a lot of ways. But what's fascinating is that even with all that unpredictability, we can still say some pretty reliable things about these systems, like take climate change. The scientific consensus on human-caused climate change is really solid. The source mentions some great papers here, Mayer et al. And Lewandowski et al., that lay out the evidence.
So yeah, the big picture might be pretty clear.
But the details, how we got to that big picture and what kind of uncertainty is still there, that's where philosophers can really dig in. McKinney and Schrader-Frechette have done some important work on this. How sure are we about our knowledge? What does it even mean to be uncertain in these situations? And how should we act when we know we don't have all the answers? These are all big philosophical questions.
Absolutely, big questions.
Yeah.
Okay, the source also gets into objective risk and subjective risk. Objective risk is basically the frequentist idea of probability, where you look at how often something happens over a bunch of trials. But subjective risk is a lot more complicated.
Yeah, it's not just about the numbers. In psychology, subjective risk was first thought of as just your personal guess about the objective risk.
Right, just your best guess.
But now we know it's way more than that. It's affected by things like how much control you think you have over a situation, or whether you think something is messing with nature in a way that feels wrong. It's all tangled up with your feelings and beliefs about the world, like I might feel less scared of flying if I really trust the pilots, even though the statistics about plane crashes haven't changed.
Yeah, that makes sense. So the source actually says that the term risk perception is kind of misleading. People use it to mean your overall sense of how dangerous something is. But it's not just about seeing the risk. It's also about your attitude towards it, what you believe about it, and what you expect will happen.
Right. It's much more than just a cold calculation. It's emotional.
Yeah. So researchers study this stuff using methods from psychology, like they look at people's attitudes and how they rank different risks. And then the source talks about this other way of thinking about risk called the modal account, which was put forward by Pritchard.
I really like this idea. It gets away from probabilities entirely. Instead, it says that risk is about close possible worlds. So the closer the nearest possible world where something bad happens, the greater the risk is. It's not about how likely it is in this world, but how easily things could have gone wrong in a slightly different world. It's a fascinating way to think about it.
Wow, that's really interesting. So you're not just looking at cold, hard stats. You're thinking about all the ways things could have been different.
Exactly. And the source points out that it connects nicely with those psychological accounts of risk perception we were talking about. But there's a catch. How do we actually define and measure the closeness between these different possible worlds? That's a whole other philosophical can of worms.
Yeah, definitely. And I think it highlights that we're still figuring out how to think about risk in a way that makes sense of both the objective facts and our subjective experiences. Okay, let's shift gears a bit and talk about what the philosophy of science has to say about risk.
Yeah, great. One of the biggest issues here is the role of values in science. It gets pretty controversial, especially when you're talking about risks.
I can imagine. So one of the big criticisms is that risk assessments often aren't as objective as they claim to be.
Right.
They can be influenced by all sorts of hidden values, which
Yeah.
might lead us to accept higher levels of risk than we really should, ethically or socially.
And then there's the flip side. Some people argue that we should actually be more upfront about incorporating certain values into risk assessments, like justice, human rights, the well-being of future generations, that sort of thing. The source mentions Schrader, Frechette, and Caney here. They've written a lot about this.
So it's about being more deliberate and transparent about what matters to us when we're evaluating risk. And I can see how that ties into those debates about how much scientific evidence you need before making big policy decisions, especially when those decisions involve risk.
Definitely. Science usually demands really strong evidence to avoid making mistakes, but sometimes waiting for that level of certainty could be really dangerous.
Like if we're talking about climate change or a new pandemic, every delay could make things way worse.
Exactly. And that brings us to this idea of inductive risk. It's a term from Carl Hempel, a philosopher of science. It's about the risk that you're wrong when you accept or reject a scientific claim based on the evidence you have.
Right. So there's the risk of a false positive thinking something is true when it's not. That's a type I error. And then there's the risk of a false negative missing something that's actually true. That's a type 2 error.
And traditionally, science is really focused on avoiding those type I errors, those false positives. That makes sense because you don't want to mess up the scientific record with stuff that isn't really true.
But like you said, sometimes a type 2 error missing a real danger can be way worse.
Exactly.
The source uses the example of a defect in an airplane engine.
A very powerful example.
A type 2 error there, thinking the engine is fine when it's actually dangerous, could lead to a plane crash. So in that situation, it makes sense to be super cautious, even if it means you might ground some planes unnecessarily because of a false positive.
Absolutely. Better safe than sorry in that case. And the source makes this point that usually when we're talking about risk, the thing we're studying is pretty clear. That helps us understand the difference between these two types of errors.
Right, clear definitions matter.
The source actually has this really cool diagram, figure 1, that shows how scientific data can influence both the official scientific knowledge and the decisions we make in the real world.
Oh yeah, I remember that diagram.
So it shows how data goes through this rigorous process of peer review and all that to become part of the accepted scientific knowledge, that body of knowledge that scientists agree on. And that process is super strict. They're really trying to weed out any false positive.
Right, they want to be absolutely sure.
But then when it comes to making policy, we usually just rely on what's already been accepted as scientific fact.
But what happens when the data is suggestive, but not quite conclusive yet? Like maybe there are some early toxicology studies that raise red flags, but they haven't been fully confirmed yet.
That's where things get tricky. That information might not be officially science yet, but it could still be really important for making good decisions about risk. So the source suggests that in some cases, it might make sense to have a more direct path from that data to action, even if it hasn't been totally proven yet. We might need to take precautions based on what we suspect, even without 100% certainty. It all comes down to balancing the risks of a false positive and a false negative, and that balance might change depending on how serious the potential consequences are.
So, what counts as good enough evidence for science might be different from what counts as good enough evidence for making decisions about public health and safety.
Exactly. Two different standards of evidence, two different goals. And then the source talks about epistemic risk, which is a broader way of thinking about all of the risks involved in forming beliefs. It's not just about accepting or rejecting a hypothesis, it's about all the choices we make along the way, the methods we use, the assumptions we make, how we interpret data.
So uncertainty is like built into the whole process of doing science, not just the end result.
Yeah, it's part of the game.
And unfortunately, we also have to deal with disinformation campaigns like science denial and stuff like that.
Hmm.
These campaigns are specifically trying to manipulate how people understand and respond to risk. And the source points out how important it is for philosophers to fight back against those campaigns.
Absolutely. We have to call out bad arguments and defend good science, especially when it comes to issues that affect people's lives.
Okay, let's shift gears again and look at risk from the perspective of the philosophy of technology. Safety and avoiding risk are obviously huge deals in engineering, right?
Oh, absolutely. Keeping things safe is job number one for engineers. And the source points out that even though people are studying safety engineering more and more, the research is still kind of all over the place. Different fields of engineering have their own ways of doing things.
But it's interesting that a lot of the basic ideas about safety seem to be the same across different fields, even if they use different words for them. They have these core safety philosophies.
Yeah, like a shared set of principles. And the source focuses on three really important ones: inherent safety, safety factors, and multiple barriers. Let's start with inherent safety. This is all about getting rid of the hazard altogether, like preventing the dangerous thing from even existing in the first place.
Right, so instead of trying to control a fire, you just don't use flammable materials in the first place.
Exactly. It's about eliminating the risk at the source. And the source contrasts this with what they call secondary prevention, which is all about reducing the risk once the hazard is already there, like having fire extinguishers. But inherent safety is usually better because even with good safety measures, unexpected things can still happen.
Yeah, you can't predict everything.
Right. And then there's safety factors. These are basically like extra margins of safety that engineers build into their designs. They make things way stronger than they need to be under normal conditions. So like a bridge might be built to hold 2 or 3 times more weight than it's ever expected to actually carry.
Okay, so it's like building in a buffer, just in case.
Exactly. And safety factors aren't just for bridges and buildings. They're also used in toxicology and things like that, where you're setting safe levels of exposure for people to chemicals. And in those cases, the safety factors can be huge, like 100 times lower than the level that seems to cause problems in animal studies.
That's a pretty big safety margin. What about multiple barriers?
Yeah, multiple barriers are all about having layers of protection. Like, imagine an old castle with lots of walls.
Okay, so if one wall falls, there's still more behind it.
Exactly. And in engineering, those barriers can be physical, like the castle walls, or they can be spread out in time or function, like different safety systems that kick in at different stages of a process. The Souls actually talks about the Titanic here, which is a really sad but important example. The Titanic had some pretty good safety features, but it only had enough lifeboats for about half the people on board. So even though the ship was designed to survive hitting an iceberg, that one failure in the later stages led to a huge tragedy.
So the lesson is you can't just focus on the first line of defense. You need to have backup plans and backups for your backups.
Absolutely. And one of the biggest challenges with multiple barriers is making sure they're truly independent of each other. If they can all be taken out by the same thing, then having a bunch of them doesn't really help that much. It's like having 3 fire extinguishers in the same room. If a fire breaks out, they might all be useless.
Right, that makes sense. It's not just about quantity, it's about diversity.
Exactly. And what's cool about all 3 of these safety principles, inherent safety, safety factors, and multiple barriers, is that they're not just about protecting us from things we can predict and calculate. They're also about those totally unexpected, unknown unknowns, the things we can't even imagine happening.
That's a scary thought, the stuff we don't even know we should be worried about.
It is a little scary, but it's reality. And the source argues that philosophers have a lot to contribute to this field. We need to think more about the basic principles behind safety engineering and how those principles connect to our broader ideas about design and technological risk. Like, how do we design systems that are resilient to the unexpected, the stuff we haven't even thought of yet? That's a big challenge for philosophers and engineers.
Totally. And even when we think we've got all our bases covered, the source emphasizes that it's still super important to keep an eye on new technologies after they've been released into the world.
Right, it's called post-market surveillance.
Yeah. Because even with all the testing and stuff that happens before a new technology comes out, there might be problems that don't show up until it's being used by lots of people in all sorts of different situations.
It's like that example with the early airbags in cars. They ended up causing certain types of injuries that no one had anticipated, so they had to go back and redesign them.
Wow, I remember that. So post-market surveillance is basically about learning from experience and making improvements along the way.
Exactly. And for some technologies, like new drugs and medical devices, post-market surveillance is actually required by law.
Makes sense. Okay, let's move on to ethics. Risk obviously raises all sorts of moral questions. It's interesting that the source points out that moral philosophy hasn't really focused on risk in a systematic way until relatively recently.
Yeah, that is a little surprising.
Why do you think that is?
Well, the source suggests that maybe it's because moral philosophy has traditionally been more interested in situations where things are clear-cut, where the outcomes are certain and the choices are well-defined. And risk, by its very nature, is all about uncertainty.
Yeah, okay, I can see that.
So maybe philosophers figured that decision theory was a better tool for dealing with that kind of messiness.
But the source argues that it's not that simple, right? They use this really cool example, dropping a brick on someone versus dropping a brick without checking to see if anyone's underneath.
Yeah, that's a really thought-provoking example. Clearly, there's a big moral difference between those two actions. But that difference isn't just about how likely it is that someone will get hurt. It's about your intentions and whether you were being reckless.
Right. So a proper ethics of risk needs to be able to deal with those nuances.
Well,
It needs to distinguish between intentional harm and unintentional harm, and between risks that people freely choose to take versus risks that are imposed on them.
exactly. We can't just reduce everything to probabilities and outcomes.
So what kind of tools do we need?
Well, the source starts by looking at how some of the big moral theories try to handle risk, especially when it's framed in terms of probabilities, like in decision theory. Let's take utilitarianism, for example. One way to apply it to risk is to just focus on the actual outcome. So if you don't reinforce a bridge and it doesn't collapse, then you were right not to reinforce it, even though there was a risk that it would collapse. That's called the actualist solution.
But that doesn't feel quite right, does it?
Yeah.
Like you were still being irresponsible by not reinforcing the bridge, even if you got lucky and nothing bad happened.
Right. It goes against our gut feeling that you shouldn't take unnecessary risks, even if you get away with it.
So the more common way that utilitarians deal with risk is to try to maximize expected utility.
Yeah, where you calculate the average utility of all the possible outcomes weighted by their probabilities.
But even that approach has some problems, right?
Yeah, definitely. Like, it can lead to situations where you're willing to accept a higher risk of a small number of deaths if it means avoiding a tiny risk of a huge number of deaths. And that doesn't seem right.
Like we should be more concerned about preventing a catastrophe,
Yeah.
even if it's unlikely.
Exactly. And it can also lead to situations where it seems okay to impose a high risk on a few people if it benefits a lot of other people, even if that benefit is pretty small for each individual.
So maximizing expected utility can sometimes lead to outcomes that feel unfair. But the source makes an important point here. Maximizing expected utility isn't the only way to think about utilitarianism and risk. There are other ways to approach it, like focusing on the actual consequences or adopting a more risk-averse principle in certain situations. So just because maximizing expected utility has some problems, it doesn't mean that all forms of utilitarianism are off the table when it comes to risk.
Yeah, utilitarianism is a really broad framework. There's room for different interpretations. Okay, what about rights-based theories? Robert Nozick asked this really tough question about rights and risk. Imposing how slight a probability of a harm that violates someone's rights also violates his rights.
Yeah, that's a tough one.
It gets to the heart of how absolute rights are. Like, if any increase in the probability of a rights violation is wrong, then almost everything we do in society becomes morally problematic. Even driving a car slightly increases the risk of harming other people. So if we took that idea to its logical conclusion, no one could drive.
Yeah, that wouldn't work. So it seems like the right not to be exposed to risk has to be limited in some way. It can't be absolute.
Right, it has to be defeasible, meaning it can be overridden in some cases, especially if the increase in risk is really small.
Mm.
But then the question becomes, where do we draw the line? Nozick pointed out that with rights violations, we usually don't think there's a threshold. Like, stealing even a tiny amount of money is still stealing. So how do we decide when it's okay to impose a small risk on someone?
Yeah, finding that balance is tricky. What about deontological theories, the ones that are all about duties and rules? They must have something to say about risk too, right?
Yeah, but they run into a similar problem. If the rule is don't harm others, then it seems like that should also mean don't increase the risk of harming others. But again, that's just not practical in the real world. We have to accept some level of risk in order for society to function.
Right, otherwise we couldn't do anything.
And just like with rights-based theories, it's tough to figure out where the line is. When is it okay to break the rule and impose a risk on someone? It seems like you have to start thinking about probabilities and benefits, which aren't always central to deontological ethics. Like, a rule against killing obviously should apply if you're doing something that's super likely to kill someone. But it can't apply to everything that carries even the slightest chance of death, or we'd never leave the house. So we need some way to distinguish between reasonable and unreasonable risks.
Yeah, we need to find that sweet spot. Okay, what about contract theories? Those are all about agreement and consent, right? Maybe they have a better way to deal with risk.
That's what you might think. The source talks about the idea of actual consensus, which means that it's only okay to impose a risk on someone if they actually agree to it.
Okay, that sounds fair.
But the problem is, getting everyone to agree on everything in a big, complex society is basically impossible. Think about it. If you needed everyone in your city to agree before you could drive your car, no one would ever go anywhere. There are just too many people and too many small risks that add up over time.
Right, it would be total gridlock.
So to get around that, some philosophers have come up with the idea of hypothetical consensus. It's about what rational people would agree to if they were in a certain situation. Rawls and Harsanyi both talked about this, but they imagined different starting points.
Oh, right, they had different ideas about the original position.
Exactly. Rawls thought people should make decisions behind a veil of ignorance, where they don't know anything about their own place in society. And he argued that in that situation, people would choose to maximize the well-being of the worst off, just in case they ended up being one of those people. Harsanyi, on the other hand, thought people should know the probability of ending up in each different social position, and he argued that they would choose to maximize overall expected utility.
So two different ideas about fairness, leading to two different decision rules.
Yeah, and the source makes the point that even though these thought experiments are really interesting, they might not be super helpful for thinking about risk in the real world.
Right.
The risks we face in our everyday lives are different from the kind of hypothetical risk you're thinking about when you're imagining how to set up a just society from scratch. So those thought experiments might not give us any new tools for figuring out what's morally right or wrong when it comes to risk.
Okay, so it seems like none of the standard moral theories have a perfect answer for how to deal with risk.
It's a tough nut to crack. But the source does suggest a few things that might help. First, instead of just focusing on the risk itself, like the probability and severity of harm, maybe we should pay more attention to the actions that create or impose risk.
Okay, so looking at the whole context, not just the numbers.
Right. We should consider things like, did someone intentionally cause this risk? What were their motives? Who benefits from this risk and who bears the costs? That kind of thing.
So it's about taking a more holistic view.
Right. Exactly. And second, maybe we should start by assuming that people have a basic right not to be exposed to risk, at least when that risk is caused by other people's actions.
Okay, so a right to safety, basically.
Yeah, but that right would have to be limited in some way, or again, we couldn't do anything. So that brings up the question of when it's okay to override that right.
When is it justified to impose a risk on someone? That's a tough question.
Yeah, it's a really important one, and the source calls it the exemption problem. And one possible answer is to think about reciprocal risk-taking. Like, I take a risk when I drive my car, but you also take a risk when you drive yours. We're both exposing each other to some level of danger, but we both benefit from being able to drive. So it's a kind of trade-off.
Right. And in a complex society, that idea of reciprocal risk-taking has to apply to all sorts of different risks and benefits.
Exactly. So maybe it's okay to be exposed to some risks if it's part of a system that's generally fair and beneficial to everyone. But we also have to make sure that system doesn't unfairly burden certain people, like those who are already disadvantaged in some way.
Right. Fairness matters.
The source also mentions that philosophers are still debating a lot of these issues, like how much risk is acceptable, what does justice look like when it comes to risk, and how do we balance individual rights with the need to manage risks for society as a whole. So the ethics of risk is a really active area of philosophical research right now.
Lots to think about there.
Definitely. Okay, let's switch gears one last time and talk about decision theory, which is all about making choices when things are uncertain.
So decision theory is basically about figuring out how to get what you want when you don't know for sure what's going to happen. It takes your goals and values as a given,
Hmm.
and then tries to help you make the best choices to achieve those goals,
Yeah.
given all the uncertainty.